Thanh Tuyền, and I don't belong to any group. Today I will represent the factory method button. This slide is powered by slide deck, which means I don't have any PowerPoint file, but I will submit the shortcut of this slide instead of the PowerPoint file. To see how I write the slide in the Markdown extension. So let's begin. Factory method is a creational design button. It is also known as virtual constructor. It defines an interface for creating an object. It creates objects without exposing the creation logic to the client. And it lists the classes responsible for creating the instance of the class. So imagine that we want to create a cross-platform UI elements. So we want to create a form which will need various UI elements such as the button, the checkbox, the input, for example, and those elements must work the same on multiple operating systems. Let's say we define a button class that has a poor virtual method called render. So its two subclasses will be called Windows button and Mac button, which will override the render method. Here is the implementation of the naive solution. Of course, we will have the button parent class and two subclasses, Windows button and Mac button. The parent class have the render method, and then the child class will override the render method. And in this main method, we assume that this operating system here is Windows, and if the OS equal to Windows, we will render the Windows form by create the Windows button and then call the render method. So obviously the client needs to know detail of each button subclasses. So the client need to know that we have the Windows or the Mac button. So later, if we decide that we will support the Linux operating system, we have to change the name else if to the button for the Linux OS. So each time a name change is made at the library side, the client would need to make some corresponding changes at its end. Let's see the factory method solution. So similar to the naive solution, we have the button parent class and the two subclasses, Windows button and Mac button, which override the render method from the parent button class. And now we explicitly create a form class which have two methods, factory method and the render method. The factory method will be the virtual method, and the two subclasses, Windows form and Mac form, will override the factory method. In the render method, we will call that factory method. And then this factory method return a button um, depend on dependent on which firm we want to create, Windows firm or Mac firm, and it will call the button dot render method. In the main method, now we um, don't have any if else condition here. We just go straight forward, call to the Windows form class or the Mac form class. So here we will render the Windows form first. We will have an helper method, the client code, which will accept the form object and then call the render method. It will be similar to the Mac form. So here we see that the selection of types for object creation is totally decoupled from the client. The form subclasses are now responsible to decide which button type to create. The client just needs to make calls to the form operation method without worrying about the actual implementation of the creation of the objects. So the general solution is replacing direct object construction calls with calls to a special factory method. Override the factory method in a subclass. Usually, objects returned by a factory method are referred to as products. Subclasses might return different types of product only if these products have a common base class, which means we have to define a parent class and then we define some children classes inherit that parent class. Also, the factory method in the base class should have its return type declared as this base class. The code that uses the factory method, often called the client code, does not see a difference between the actual products returned by various subclasses. In our case, the main method just need to know that this is a firm and it will have the render method. So it just go ahead and call it. Program. So we have the product interface and two convert product classes, subclasses. And we have the creator class, which will have the create product, returns the product interface, and some other operation. We also have the two more subclasses for config creator classes. This is the class diagram of our problem. So the product here is button and it had the virtual render method. Its two subclasses are Windows button and Mac button. So the config classes are Windows firm and Mac firm, which inherits the firm parent class. Here, general code example in JavaScript. We have the creator abstract class, which have factory method, return the product object, some operations. Here we return a string, tell that this is the creator, and the config creator one extend the creator class. It override the factory method, similar to the config creator one. We have the config creator two extend the creator parent class, override the factory method. And then we have the product class, the product interface, which have operation method, And the config product one implements the product, override the operation method, similar with the config product two. So in the main function, we launch with the config creator one, pass the new config creator one statement to the client code, which is a helper function. It will print out on the command line that it is a client and call the sum operation method of the creator. Similar, we will create another instance of the config creator 2 and then log to the console and call the sum operation of the creator. Here we calling the config creator 2. So we will use this pattern when we do not know beforehand the exact types and dependencies of the objects. We want to providing library or framework with a way to extend its internal components. And we want to save system resources by reusing existing objects instead of rebuilding them each time. Um, Next, we will talk about the pros and cons. Here we can avoid tight coupling between the creator and the config products. Um, we will obey the single responsibility principle, move the product creation code into one place in the program, and we also obey the open-close principle. We introduce new types of products into the program without risking existing client. The cost here is the code may become more complicated since many new subclasses are introduced. So with the naive solution, we only have three classes: the button, the Windows button, and the Mac button. But with the factory method solution, we introduce now three new classes, which are form, Windows form, and Mac form. So we will have more code to maintain. So that's the end of this presentation. I mainly refer to Refactoring Guru website. Thank you for your time.